Hi, this video is on examples of using quadratic methods to solve equations. In this first example, we may want to jump straight to the quadratic formula, but we see that we have an x cubed, and that's preventing us from using the quadratic formula because that is set up for just a square. So how do we approach when we have a power that is too high? And we have methods we can use, such as u substitution, but this does not work for that because we cannot use a u substitution when we have this many variables. So we have too many variables for u substitution. So what other methods do we have at our disposal? If we go back to factoring, we have 4 terms, and usually when we have to factor something with 4 terms, we do what's called factoring by grouping. So let's try that. I have 2 groups right here. Here's 1 group and here's 2 groups. So what I'm going to try and do is factor these groups and see if I have something in the end that looks identical. So for the first group, I'm going to try and factor out a y because they have a y in common. So I will take out a y, and that leaves me with 2 y's in the first term and only a 9 in the second term. For the second group, I'm going to factor out a negative because they both have a negative, and I'm going to factor out a 2 because I have a 2 and an 18, which is divisible by 2. They do not have a variable in common, so I'm just going to factor out a negative 2. So I have negative 2 times y squared plus 9 because I factored out a negative. So a negative 2 coming out changes this sign to a positive and changes this sign to a positive. It's all still equal to 0, and if I double check what I have factored, I see that these 2 match perfectly, so I have 2 matching binomials. So I'm going to factor them or undistribute them. I'm going to take them out of here and put them in front. Okay, so that gives me a y squared plus 9. Okay, and if I take it out of this first term, then I have a y left over, and if I take it out of the second, I have a negative 2 left over, equals 0. And a quick check tells me that if I took this entire term, binomial, and stuck it in here, I would have y times that, which matches the row above, and here I would have negative 2 times the binomial, which matches the row above. So I factored correctly. The next step would be to set each of the binomials equal to 0 and solve. So I have y squared plus 9 is equal to 0, or y minus 2 is equal to 0. So this I can deal with pretty easily. That is just adding a 2 to both sides. Plus 2 and plus 2. These 2 cancels, and I get y is equal to a positive 2. This is a more complicated one to deal with, so we'll go to the next slide and deal with that separately. So I had y squared plus 9 is equal to 0. I'm going to move 9 to the other side, and I have y squared is equal to negative 9. I can square root both sides, so I'll take the square root here and the square root here, keeping in mind that square rooting means that I'll have a plus and a minus for my answer, and I get y is equal to plus or minus the square root of negative 9. Now, depending on whether or not you have covered complex numbers, you'll recognize this as y is equal to plus or minus 3, and then an I to make up for the negative in the square root. So that gives us a solution set of 2 from the previous slide, negative 3i from this solution, and a positive 3i from this solution. So we have our solution set for our original problem on the previous slide, this problem here, with these solutions here and here, and let me use a different color. So the entire solution is right here. Here we have a second example in which the quadratic formula cannot be readily applied. We don't know how to deal with negative powers in the quadratic formula. But we do have workarounds, and one of those workarounds is commonly referred to as substitution, sometimes u substitution, where I can acknowledge that, well, x to the negative 2 is the same as x to the negative 1 to the 2. Remember, across parentheses means multiplication, so moving the 2 inside would give me back the negative 2 that I'm looking for. I know how to deal with a variable being squared, such as m squared. This I know how to deal with, but I don't know how to work with this negative power. So what I would do is substitution, so that I can work with a positive power until the very end of the problem, at which point I would substitute the negative back in. Alright, so let's try that. I need a variable to set equal to x to the negative 1. So I'm going to say m is equal to x to the negative 1. And then I can rewrite the above equation by replacing all of the x's with m's. Okay, so I'll do that in another color. And here I have x to the negative 1 squared plus x to the negative 1 minus 30 is equal to 0. And I've already said I'm going to replace this and this with m. Okay, that would give me m squared plus m minus 30 is equal to 0. Now I have two options. I can use the quadratic formula because I'm set up in a ax squared plus bx plus c form, or I can factor. The quadratic formula can be kind of cumbersome, so whenever I see the opportunity to factor, I'm going to go ahead and use it. I know that 30 can factor to 5 times 6. These two numbers are only one digit apart, so when I see a 1 coefficient here, I know it's going to be a combination of these two numbers. So it looks like a positive 6 and a negative 5 would add to give me a negative 1, or sorry, a positive 1, and multiply to give me a negative 30. So I'm going to say this is m minus 5 times m plus 6 equals 0. Using one of our fundamental properties from algebra, we know that this tells us m minus 5 must be 0, or m plus 6 must be 0. If two things multiply to give me 0, the only way that can be true is if one or both of those things equal 0 in the first place. So let's try that on the next slide, because I'm out of room here. So I had m minus 5 is equal to 0, or m plus 6 is equal to 0. Solving, I have m is equal to 5, or m is equal to negative 6. And then I have to recall that I've already placed x with m. So I need to recall that m is actually x to the negative 1. So I'm going to replace m at this point. X to the negative 1 is equal to 5, or x to the negative 1 is equal to negative 6. If you recall from previous lectures, x to the negative 1 is actually 1 over x is equal to 5, or 1 over x is equal to negative 6. Since I have x in the denominator here, I can essentially flip both sides, or what we call cross multiplying, which would result in x is equal to 1/5, or x is equal to 1 over negative 6, which is commonly written as negative 1/6. Okay, so these are two different ways to solve two different quadratic forms of an equation. I hope this clarifies some of the homework problems, and feel free to reach out if you have further questions.